All right, hello class. This video is about graphing tangent functions. A tangent function is the sine divided by the cosine. So since tangent is sine over cosine, that actually presents a problem for us because we know that when we have a fraction, the denominator of a fraction can't be zero. So before we move on to graphing the tangent, we need to look at the cosine graph because we don't want our cosine, the denominator here, to be zero. So here's a graph of our cosine. Where is the graph of the cosine equal to 0 at? Well, the graph of cosine is equal to 0 at pi over 2, and again at 3 pi over 2, and at 5 pi over 2, negative half pi. All of the half pi values here, repeating, are where the cosine is equal to 0. All right, those are the zeros of that. Well, on the tangent graph, these particular spots become asymptotes. So these become asymptotes. So therefore we have an asymptote at pi over 2, or pi over 2 times any value of, plus any value of pi. So repeating values of pi over 2. So asymptotes of pi over 2. So when we come to our tangent graph, when we come to pi over 2, at this spot we have to draw an asymptote. And all the ones that match up here, we have to draw these asymptotes. So this is what the tangent graph ends up looking like. This is the graph of y equals tangent theta. Also notice as you look at this graph what the period of it is. The period would be the distance here of one cycle before it starts to repeat. And it's going from positive 1/2 to negative 1/2 here. So the distance between these two lines is pi. So the period is pi. In general, the formula for the period is pi over b. Now this is different than the sine wave, remember, because the sine wave, the period was 2 pi over b. But for tangent, it's just pi over b. All right, so let's talk about how to graph these. Okay, so one of the main things I'm going to want you to do for this lesson is to take something that's given to you like this, y equals a sine b theta, and I want you to be able to graph it. In order to graph it, you have to find the asymptotes first. The first thing you're going to do to graph it is find the asymptotes. So, in order to find the asymptotes, what you're going to do is you're going to compare your values on the inside with the original place where you already know the asymptotes were or are for tangent. So we're going to take whatever they have on the inside here, and we're going to set it equal to where we know the asymptotes are for tangent, which is pi over 2. So take whatever value they have and set it equal to pi over 2. Then you can solve for the angle, and that will let you know where it is. So find the angle that will give the original asymptotes. Then once you have your asymptotes, one of them will be at the positive value that you get, and one of them will be at the negative angle value that you get. All right, and then you'll just be able to measure the distance here, and then use that period to keep repeating that same distance and keep on drawing your asymptotes. Okay, so first we're going to find our asymptotes by setting our whatever's inside the tangent equal to pi over 2, and then we're going to place the value of a. Whatever this value of a here is, well, we know it's not just the amplitude of the graph, because tangent is going up forever, right? There's no cap on it. The range continues forever here, right? But it is a vertical stretch. That value of a is stretching it vertically. So what we have to do is we're gonna find in the middle here between the 0 and the asymptote, right in the middle, we have to put a dot. We're gonna put a point on the graph there up at the value of a. And then on the other side, halfway between the 0 and the asymptote, down at negative a. So halfway to the asymptotes on each side of the 0 is where you graph a, and that a is a vertical stretch. So, great. Let's look at a couple of examples of how to graph tangent. Okay, so the first equation that we're going to try to graph is y equals 3 sine 2 theta. Okay, the first step to graph this is to find the asymptotes. To find the asymptote, I'm going to take my value on the inside here, and I'm going to compare it. I'm going to set it equal to where I know what the asymptotes are for tangent, which is pi over 2. So what I have is 2 theta equals pi over 2. Now I'm going to solve for theta. To solve for theta, divide both sides by 2. This gives us pi over 4. Okay, so that looks like our asymptotes are going to be at pi over 4 and negative pi over 4. Our asymptotes are at positive and negative pi over 4. So let's get ready to draw this. Okay, and let's just count by fourths since we have pi over 4 is what we're trying to get to. Okay, so 1/4, 2/4, 3/4, a full pi. So 1/4 pi is here. And we can mimic that on the other side. So our asymptotes, go ahead and draw them in. Now we're going to use our A value, which is our vertical stretch. So the value of A in this problem is 3. So coming halfway between the 0 and the line here, well, first of all, we're going to have a dot at 0. Okay. Then halfway between here and here, I need to come up to 3, down to negative 3. Now I can draw in my function. Okay, let's try to draw another cycle. If I want to draw another cycle, I'm going to have to repeat the same shape over and over. So it would be nice if I knew what the period is. How wide is the graph from here to here? So if I can know the period, then I can repeat that same distance over and over. So now the formula for my period is pi over b. Okay? And pi over b in this case, our b is 2. So I'm going to have pi over 2. So my period is half pi. And that makes sense, right? Because if this is a fourth and this is a fourth and a fourth would make a half. So here's a half pi. Let's go ahead and go another half pi and draw our next asymptote and follow the same procedures to mark in the vertical stretch. Let's do one more example. In this example, let's find the asymptotes first. So the asymptotes are going to be, I'm going to take this part inside here and set it equal to where I know my asymptote should be, which is pi over 2. So I have pi over 2 theta from right here equals pi over 2, which is always the same, always equals pi over 2. Well, it looks like I have a pi over 2 on both sides here. So the pi's over 2s are just going to cancel, and looks like my angle that gives me that pi over 2 is 1. So theta equals 1. That means my asymptotes are going to be at positive 1 and negative 1. Let's get ready to draw it. Okay, good. So my asymptotes go at 1 and negative 1. Okay, now let's draw on the graph. It looks like my amplitude this time, or not the amplitude, but my vertical stretch is negative 2.5. Since the A value is negative, instead of starting up 2.5, I'm actually going to come over and start down 2.5. So let's see, 2.5, and draw in our function. Okay, and let's make one more period. What is the period of this graph here? Well, the period, it looks like it goes from negative 1 to 1, so I could just count. My period is 2. But let's also just do our period equation. The period is pi over b. Pi over 2. Okay, so let's multiply by the reciprocal of this denominator to get rid of that. Okay, down here it's all going to cancel, and in the numerator the pi's cancel and I have a 2 left. So the period does in fact equal 2. Let's come over 2 from the 1 and draw in our next asymptote at 3. So now I can put my dot right in the middle of here at 2. And halfway between there, we are down to negative 2.5. And halfway between here, we're up to positive 2.5. All right, a little bit messy, but that is how we graph tangent. Great job.